Inbound on a radial of 0 degrees, pilot rotates OBS 10 degrees to left and turns the aircraft right by 10 degrees and notes the time. While maintaining a constant heading, it is noticed that the CDI is centered in 8 minutes. Considering nil wind conditions, based on this, you can conclude that the time and final heading to station will be, and these are the options. I'll give you some time.
Yeah,
What do you have?
I think so.
The time, yeah, because speed is equal to distance by time. So
Yeah.
let's put this into a diagram here. You're coming inbound on radial 090. If we assume that we have already OBS 090 because we are already coming inbound on 090 radial. So let's draw the VUR here. Let's draw the 090 radial. So all these basic things, now you're masters of VUR anyway, so you know. This is 090 radial. You're coming inbound on this radial. Now what does the pilot do? He rotates OBS by 10 degrees to left. So if you look at the OBS dial, or if you look at the general CDI dial, if I start from, say for example 0 and this is 90, it is OBS to 90, right? Initially it is OBS to 90. So now when I turn the OBS by 10 degrees to left, what will be the new OBS? Will be 80. Turning it to the right will increase the value, to the left will decrease the value. Therefore, the new OBS is 80. Now what's the meaning of that? That is going to now make your current radial 090, but the selected radial will be 080. This is a new OBS. Now, if I am on the 090 radial, and if I want to now intercept 080 radial, since I am coming inbound to station, what direction should I fly?
Right.
I have to fly right. Right? But what is the sensing here? I'm coming, on what side am I of the OBS radial? I'm on the front side. And I'm coming to the station. Therefore, it's a reverse sensing. And since I have to fly right, my CDI will automatically tell me to fly left. Right? But I have to fly right here. So that's what the pilot is doing. He's turning his heading 10 degrees to right. So what is his current heading?
270.
270. The current track to station is 270, but since there is no wind, your track is equal to heading. Right? Therefore, the current heading is 270, and the pilot changes his heading by 10 degrees to right. Again, a right heading change will cause an increase in heading by 10 degrees. Therefore, what is the new heading? 280, right? So now the pilot is now changing the heading by 10 degrees to right, and that's going to be 280. Now he is tracking this 280. Can you draw the CDI indication here? At the time of leaving this radial over here, what is the OBS radial? 080. And assuming a 5-dot system, 2, 3, 4, 5-dot system, what flag is it?
It's a front flag.
It's a front flag because I'm on the front side. And what is the difference here? Degrees difference?
10 degrees.
10 degrees.
5 dots fly left.
Corresponding to 5 dots, right? Since what am I supposed to do? I'm supposed to fly right, but since it is reverse sensing, this will ask me to fly left. Fly left by 5 dots, but I have to fly right. Now you see, I'm flying right from 270. Now my heading is 280 because I want to fly right. That's why the heading was changed to 280. Now I keep flying. What happens to this needle? Well, if you observe the CDI, what do you think is going to happen to this needle as I keep flying and as I'm approaching the 080 radial? What is going to happen to this needle? This needle is going to come all the way, and when you are exactly on 080, it is going to get centered. So centering happens when you are on the 080, when you're exactly on the 080 radial. And how long did this take? This took 8 minutes. This is the 8 minutes they're talking about. Now, I was coming inbound on 090, ATC wants me to come inbound on 080. So now I have to come inbound on 080. Right? So what is the track that I have to fly if I want to track towards station? Since I'm on radial 080, track to station is going to be 260. Right? Therefore, track to station is going to be 260. That is the first question that they have asked. You can see there's only one option with 260. That itself should help you to actually pick up the answer. But let's also find out what this is. What is the next question? They ask you to find time and final heading to station. You see, final track to station is 260. Therefore, what is the final heading?
Same only, nil-win condition.
It's a nil-win condition. Therefore, your final heading is also 260. Now they're asking you the time to the station. So after interception, how long will it take for you to reach the station? You have to find out this time as well. Right? Do you want to take some more time to find out this time now? Oh no, I'll tell you. You have taken time. That's okay. So you look at this triangle here. Do you understand the question? Do you understand how we got 260 heading?
Yes.
And did you understand what are we trying to find out now? I'm trying to find out the time from interception to the station. This time is only 8 minutes, I know that, right? Look at this triangle here. Right? This angle is how much? It's 10 degrees. What is this angle? 270 and 280. Therefore, what is this?
10 degrees.
10 degrees. So I'm looking at a triangle with both the angles 10 degrees. What is this triangle called?
Isosceles.
This is called an isosceles triangle, right? What is this angle here?
160.
160, because total sum is actually 180. The 160. This kind of a triangle is called as isosceles triangle, where you have two of the angles equal. When the angles are equal, the side opposite to those angles are also equal. That is why we say that a triangle with two equal sides and hence two equal angles is called as an isosceles triangle, right? So look at this triangle here. This side is equal to this side. Doesn't look like that because I've drawn not in a proper way, but if you draw it properly, these two sides will be exactly equal. So this side is equal to this side. Understood? If I assume a constant ground speed, remember nil-win conditions, if I don't change my task, I'll be having a constant ground speed. The time taken to cover this distance will be equal to the time taken to cover this distance, because these distances are same. And if I assume a constant ground speed, if this is 8 minutes, this is also going to be completed in 8 minutes. Understood? Clear? That is why 8 minutes here. Now I had a student who came back to me, and he was the only one who came back to me, that's why I remember, saying that we had learned a formula. I'm not sure whether you thought about this formula now. Time to station minutes is equal to time change by bearing change into 60. So here you're asked to find time to station. What is the time change here?
8 minutes.
Now the time change from here to here is 8 minutes, corresponding to a bearing change of 10 degrees.
10
right?
degrees.
So it's 8 minutes into 60 divided by 10 degrees. What is the answer?
48 minutes.
48 minutes. Look at this thing here. So you have an answer for 48 minutes, but the heading is not correct, but you have that answer of 48 minutes. Right? So he asked me like, sir, why isn't this the answer? Because it's the exact same type of question. Time change is there, bearing change is there. Then but the answer is 48 as against the 8 minutes that we have seen here. Now can you tell me why this is definitely wrong? But can you tell me why is it wrong? I can apply 160 here because the angle is definitely less than 20. I can apply 160, there is no problem. But still, this is not what you should be doing. That's the problem. So in case of those questions dealing with this time to station, if you look at the diagram,
We had the straight line only, like
you're somewhere close.
straight path of the aircraft. Here we have
So I take a bearing of say 30 degrees here, and then I take a bearing of 90 degrees, relative bearing of 90 degrees at 920. Therefore, what is the, sorry, not bearing change, I'll keep it say, maybe I'll take it 75 degrees here. Therefore, the total bearing change is 15 degrees over say 10 minutes. And then I can write 10 minutes divided by 15 to 60. So if you look at those questions, it's somewhat of this format. At 9 o'clock, you took a bearing of, relative bearing of 75 degrees. At 9:20 took a relative bearing of 90 degrees to a NDB. It took 10 minutes, sorry, not 10 minutes, 20 minutes and 15 degree change. So you just do 15 divided by 20 into 60. That's going to be 45 minutes. So time, what time is this? This time is from the point of closest approach. There is a time from the closest approach to the station. And you find the distance, fuel consumption, all those things. This is not the point of closest approach. Right? And if you want to find that point of closest approach, you have to find at 90 degrees relative bearing or 270 degrees relative bearing. For that, you have to, what is the current radial of the aircraft? You have to kind of keep flying all the way until you can find out something that is a point of closest approach. If I want this VOR to be on a relative bearing of 270 degrees, what radial should the VOR be? So what is 90 degrees left of 280? It's 280 minus 90, which is 190. Right? So this is going to be 190. So if this was 190, what is this radial? That's going to be 10 degrees. So I have to go all the way to 10 degree radial. And when I intercept not 80, but when I intercept 10 degree radial, that is when I'm at the point of closest approach, and then I have to find that time. In this case, that is not required. I'm just explaining this because he came up with this idea. So we cannot use that equation here because it is not asking for time from closest approach. The point of closest approach, it's asking you time from this particular point where it intercepts the 80 degree radial. And therefore, since this is equal to these two sides are equal, assuming a constant ground speed, the times are also equal, so it's 8 minutes.